Hello, this is my English speaking practice, and I'm working on coding problems. Today's problem is Game of Life. And okay, according to Wikipedia's article, the Game of Life, also known simply as Life, is a cellular automation devised by the British mathematician John Horton Conway in 1970. The board is made up of an M by N grid of cells where each cell has an initial state, live represented by a 1 or dead represented by a 0, and each cell interacts with its 8 neighbors, horizontal, vertical, and diagonal, using the following 4 rules taken from the above Wikipedia article. Any live cell with fewer than 2 live neighbors dies as if caused by underpopulation. Any live cell with 2 or 3 live neighbors live on to the next generation. Any live cell with more than 3 live neighbors dies as if by overpopulation. Any die cell with exactly 3 live neighbors becomes a live cell as if by reproduction. Interesting. The next state of the board is determined by applying the above rules simultaneously to every cell in the current state of M by N grid board. In this process, birth and death occur simultaneously. Given the current state of the board, update the board to reflect the next state. Note that you don't need to return anything. Just once, applying just once, right? So basically the live cell in this case one neighbor, so this cell would die because of underpopulation. So yeah, it turns into 0, and the only one rules for died cell. Died cell with exactly 3 live neighbors becomes a live cell as a reproduction. So when we look at died cell, we have to we only have to check the only one condition. There are 3 lived cells, so this one, just 1, this one 2, this one 3, so this cell would live by reproduction. This one, nothing happened. This one, nothing happened. This one has 3 live neighbors, so it be 1 and 0. Okay, and 2 or 3 live neighbors lives to next stage. Okay, so this one have 3 neighbors. This one have 1 neighbors. Yeah, rule 1 applied, so this is dead. And this one is can live. Okay, this one can live. Okay, and more than 3 live neighbors dies. More than 3. but it don't happen in this example, right? Yeah. Okay. Just apply this rule. And the constraints, the board is not big. And their follow-up question, could you solve it in place? Remember that the board needs to be updated simultaneously. You cannot update some cells first and then use their updated values to update other cells. In this question, we represent the board using a 2D array. In principle, the board is infinite, which would cause problems when the active area encroaches upon the border of the array. How would you address this problem? Anyway, let me solve this in the naive solution. So the naive strategy is like check the cell and look around it and apply the rules, right? If it's lived cell, we have to check three conditions. But it's easy because based on the number of lived neighbors, we can determine which one should be applied, right? And yeah, likewise, we can apply the died cell to the fourth rules. So this is not difficult, but in place solution we cannot apply one by one, because if the cell updated, the result of the next update could be changed. So let me think. In place. But But it's impossible. It seems impossible to solve this problem without allocating extra space, I think. So the space complexity would be n times m, I think. We have to prepare a clone of the board, right? So so we have to defined hash map and its key would be the index of the 2D board, and the value would be 1 or 0, right? So it's integer. And which is m? Which is n? mn. M times n. M is I think, and for we are going to take a look at one by one, right? So range n and for j in range m, and we get the cell board ij. At the same time, we have to look around. Look around dx minus 1 0 1, and for dx in d, for dy in d, and di and dj equal j plus dy, and if dx equals 0 and dy also equal to 0, we continue it because it indicates itself. So we can look around it, and we want to count live neighbors, 2 live neighbors, 2 or 3 live neighbors, 3 live neighbors, 3 live neighbors, yeah. So lives, we have to count, and we also take care the boundary. So if di or continue, it's invalid if dj less than 0 or m dj, it's invalid as well. Yeah, so we can get valid neighbors. So if both di dj, yeah, if it's lived cell, we can count up and return the count, right? Okay, and yeah, if cell is 0, it means if the cell is dead, exactly 3 live neighbors becomes a 0. Okay. So yeah, we have to get live neighbors here. The name is not good. Look around, get live neighbors, get live neighbors, and provide ing. We can get live neighbors, and if live neighbors is 3, reproduction happens. So we can update it. Update ij should be 1, right? Otherwise live neighbors is fewer than 2. It would die under population. So should be updated ing and 0. Else if live neighbors more than 3. overpopulation. So we can merged it. 2 or 3 live neighbors lives on to the next generation. So we don't need to do anything, right? And after that, for kv in updated informations. Maybe we can deconstruct like this from k, right? And bold I j should be updated. That's all. Let me check. Runtime error, cannot unpack an iterable in object. Okay, k0, k1. Let me see. Int object is not subscript. Huh? K items. I forget the syntax. Okay. Why 2? J. It's V. Alright. Great. So yeah, I believe this is the in-place solution. We just use default dict. We just use hash map like this. And yeah, in my understanding, we cannot solve this without extra space like this. So this solution could be this solution's space complexity is m by n, because every cell could be updated, so the number of items in this hash map could be n by n, right? Yeah, n by n. Yeah. That's my understanding. And let me see this question. We represent a board using a 2D array. In principle, the board is infinite, which would cause problems. when the active area encroaches upon the board of the array? How would you address these problems? Which means to the array, assuming finite board or infinite board. Encroach. This which is not questioning. The board is infinite, which would cause the problems when the active area encroaches the border of the array.「原理的には盤面は無限であるため、活動している領域が配列の端に近づく。つまり生きているセルが配列の境界に達すると問題が発生します。」っていうと、I see. So, okay, so the problem worries about the evaluation of the cell that leaves border of the board. Would be inaccurate because we represent the board with 2D arrays, so we ignore the we ignore the cells around it like this. So I would address this problem. I assume the cells. I assume that the cells outside of the board is dead. Because so we don't count the live cells out of board like this. So I think I can address these kinds of problem. I see, but I see what the problem want to say. So for example, if this is let's assume the cell is 1, so the cell is like 1 1 1, and think about this position. This is not represented in the board because it's outside of the board, but the board is infinite, and we can assume the outside of the board all zeros, right? Yeah, at the first time. But in this case, 1 1 1. So to these cells, yeah, the cell have three leaf cell around itself, right? So this position, the cell at this position should be yeah, should be lived, should live, should turn into lived cell, right? Hmm. So we have to expand the board. As we apply the rules. Yeah, as the generation advances. That's difficult problem. Because it's just going outside, just expanding outside. All right. Okay. If the space is infinite, so which means we can use infinite memories. I would implement this like symmetric. So I mean set the position to the center of the board, and yeah, the board would be expanding. So yeah, in order to make it easy to implement, yeah, I would set the position, base position, set the base to the center of the board. Wait, but index would be minus. Index would be minus. So we have to handle this. Okay. So how to handle the negative indices? How do you handle the negative indices? When the board needs to expand the generation advance, there are few standard ways to handle it. Your intuition about centering is common, but you're right that negative indices become an issue if you stick to a plane to the array. Here are practical approaches from simplest to more robust. Dynamic resizing with margins. Keep using 2D array but surround the active area with a margin. Before each generation, check whether any live cell is close to the border. If so, expand the array. Start with reasonably large board. Track the bounding box to live cell. Bounding cell. If the bounding box is within, say 1-2 cells of the edge, create a large array and copy the old board into the center of the I see. Mm-hmm. 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 Logical coordinates offset. Separate logical coordinates from array indices. Separate logical coordinates from array indices. Treat the real board as having coordinates like xy that can be negative. Map them to array indices using offset. Allocate a large array increase offset so the old board lands in the center. Increase offset so the old board lands. All game logic uses logical xy new arrow indices. Correct infinite behavior options. Don't use a 2D array at all. Store only live cells using a set or map. For each live cell, consider its neighbors. Count neighbors using a hash map. Compute the next generation from those counts. Makes sense to me. Truly infinite board, no resizing, very efficient when the board is mostly empty, more complex logic, less cache-friendly than Alice. Yeah, but it would work. Chunked tiled board. Divide the infinite board into fixed size chunks. Store chunks in a map keyed by chunk coordinates. Scales extremely well. Used in high performance long running simulation. Really? Sports set. Yeah. So this idea is similar to option 3. Yep, that makes sense. Anyway. Yeah, good. 100% beats. 98% beats. Great. Okay. That's all. Yes. Let's call it a day. See you. See you tomorrow. Not tomorrow. See you again. See you again. Bye.